up, everybody? We are back at Data Innovation Summit 2023 with a expert panel session with a title that is the longest title ever made. Namely, Panel 4, Data Ops, Data in Motion, and Event-Driven Architectures 2023 Trends and Challenges in Data Engineering. And that's what we're here to talk about today. We have three. Now, I'm not an expert at anything really, but we have three people that are quite senior and experts in their respective fields. Please introduce yourselves.
Yeah, so my name is Stellwall. I work as a field CTO at Snowflake, so my role is to talk with customers, how they can adopt Snowflake in the cloud and so on and so forth. So.
All right.
My name is Karabiben. I'm a staff engineer at Zendesk. Before that, I've been building data platforms at companies like FactSet, Crédit Agricole. So I've had my fair share of data platforms and different data architectures that I worked on.
Okay, I'm Keith Bolam. I work for Actian, Director of Strategic Initiatives. I work with the field and the internal engineering teams to identify and guide our customers and prospects in their world of data.
All right. Well, you know, the buzz this year is language models, and it feels like a lot of the tech details have fallen to the wayside, almost as if people have said, the geeks will figure that part out or something. Has a lot of this stuff been figured out, and with particular attention to data in motion, as it were? What would you say? Have we reached a maturity level on par with plain databases that we can say that everything else relating to, you know, the types of things Snowflake does, is it all figured out? That's a trick question, right?
Yeah, that was a nice question. I don't. Is everything ever figured out? I think that is the thing. Is there's always new things that comes. I think like everything, we are on a. I mean, it's a journey and it's a learning. There's new things coming all the way. I mean, how are we going to use large language models? How can that help us in a good way? We're trying to figure that out now. I mean, apart from having a nice chat bots and these type of things, can it actually help us to be more efficient in the way how we work with data, with my data and with others' data? So, I mean, it's a constant journey, and I do hope we haven't figured out everything yet, because then I will be out of work soon.
All right. Okay, so let's just presume that we haven't figured out everything yet. What would you say? I mean, what are the sort of innovations happening in applied, you know, data ops, data in motion? And like, what are the trends? What is the newest and greatest right now?
Yeah, for me, I think it's a very interesting time because, as you said, with many innovations happening, whether it's LLMs, whether it's new technologies and new players getting to the space, like dbt, like other tools, it's reshaping how data engineers build platforms, and it's making it easier technically for them to get to the point where you deliver insights faster and to more people within the company. So we're democratizing access to data, and that means that you actually also need to focus on areas like testing, like ensuring that the quality of the data that you're delivering is fine. And that's trickling to areas. So initially, it was mostly for batch-based pipelines where it's easier for you to perform those operations. Now it's trickling down to data in motion and to streaming data, where you want to test it, you want to ensure that what you're delivering as fast as possible and as soon as possible is actually trustworthy data. So I think it's a very exciting time because for me, we're at the start of like leveraging whether new principles or new technologies in this area.
Okay. What would you say?
So I think data in motion, let's take that one to start with. There's always data in motion, and there's now more data in motion than there has been forever. You know, we're doubling the amount of data which we're processing all of the time. And it's looking after that at the edge now, I think, is very critical. The trend there is to make sure that you're only sending real data that's actually interesting into the mothership, as it were, the cloud, as we all term it these days. Being able to reprocess that garbage data at the edge is, before sending it on, if it's ever going to be sent on, I think is a critical part. That's one side of things. And the governance of the data, I think that's very critical, to make sure that the governance of the data you've got for its security, privacy, etc., that is actually a main factor which is driving the data in motion. Plus the fact that we've got an awful lot of kind of AI-built capabilities now for actually moving data from A to B. So when it's moved, you don't know exactly what's going to come out the other end. And I think that is a critical aspect as well. Yeah.
We used to have architectures, like the Lambda architecture and
Yeah.
whatnot, to try and achieve a lot of these things. Are we post that kind of architecture nowadays, thanks to technologies being performant or whatnot?
Yeah, we might be, but I think it's still valid, different types of architecture, because depending on the different types of use cases, I mean, we usually, as a product as Snowflake is, we usually is in the receiving end of, if we talk about data in motions, it usually ends up with us. So I think we have a valid use case for many of them, but I also think there's not one of them that solves everything for us.
Okay.
I think we need to have a bit of a flexibility in the regards to what we want to solve and how to want to solve it, because there's different areas to look it from. So I don't see, there's no one architecture that rules them all.
Right.
I think it's more dependent on what is the type of area. Are we talking about data in movements, real-time data? Are we talking about analytics as an area? Of course, there's interconnections between, but I would say it's different types of architecture that solves different types of problems.
Okay.
So.
What do you think about architectures? Is that something that, I mean, are tools converging in such a way that makes architecture obsolete and that you more focus on the use cases and whether you do it batch, or you don't think of it as batch or streaming, maybe it's all the same nowadays?
Yeah, I think I totally agree, but it depends on your actual use cases and what are your needs. Do you actually need it to be in streaming or not? Like streaming historically has been something that comes with a lot of complexity, with a lot of constraints, and that limited the architectures that data engineering teams can actually play around with, can actually experiment with. Now I think we're getting to an area where batch pipelines have a lot of foundational blocks like software engineering best practices and doing it at scale with tools like Snowflake. That makes it easier to now focus on the use cases where you do need the streaming data that you didn't actually implement because of the complexity, and trying to see how you can actually leverage those tools or implement streaming pipelines that leverage the same principles. I do think that eventually we can have hybrid models where you have streaming data and also batch data within the same architecture, but it will also depend on the complexity of the tools we're using and the complexity of the architecture. So eventually I think we'll get there. It's a matter of the complexity of the tools and the use cases that we have for them.
Right.
Yeah, I'd go along the lines of saying that the data velocity, transactions coming in, you've got to moderate that for the big engines. They can handle large batch inserts and things like that, batch loads, whereas a more flexible, event-driven side of things, the architecture which actually picks up the transactions, makes a decision based on it, and then either stores it or throws it away. The amount of information which comes out of, for example, some clickbait data, so you're like, whether your mouse is hovering over, whether it's clicked or something, or it's not moved for 5 seconds, all those bits of information seem to be gathered by the aggregators, pushed down a stream. Trying to store that or actually handle those transactions in one place is going to be a nightmare. It is a nightmare, and I have dealings with 100 million transactions in a minute going through. Other people who want to do 150,000 a second at peak rates. Now, that is almost impossible to handle in one single unit, so it needs to be dispersed across multiple handlers. And when you do that, yes, you can get to your multi-petabyte storage engines and then run analytics on them quite successfully. But if you were to think about trying to get real data value out of somebody who's got his hand on his mouse and he's got a bit of a jitter, you know, it might work for Bob Ross and his paintings, but whether or not it works for data and data ingest is another matter altogether.
Does performance play in this? Well, I mean, I program using the Julia language, in part because it's 300 times to many thousand times faster than Python. And I feel that if I can run an experiment in 1 minute that takes 45 minutes on Python, it changes the way I work. It's not just convenient. It changes the way I work completely. But that presumes that the work that I'm doing is valuable to begin with, right? Because if something is useless, then it doesn't matter if it takes a long time. It's like writing music. It doesn't matter that it takes me a month to write the song. I'm enjoying the whole process. There's no rush to get it done. But so when it comes to work and stuff, you know, a lot of people say, well, performance isn't important and streaming isn't important. unless you've identified that there actually is a use case for something being that fast to begin with. Do customers have a hard time identifying stuff that is valuable to have on time or not? And because I guess there's two questions baked into this. One is that there is something about the processing of the data on time, and then there's something else about the willingness of the organization to be able to take action on an instant data. For example, a shipping company being able to do same-day deliveries. It doesn't matter if a planning engine gives you a plan to do same-day deliveries if the couriers aren't actually able to drive out and that kind of stuff. So what are your experiences with, what do we call it, data in motion and organizations actually getting value from it and being able to take action on it?
I think, this is a question I almost talk daily with customers about, because it's always around, when you start a discussion, they always say, we need the data as fast as possible.
Yeah.
And then you started to figure, okay, why?
Yeah.
And what are you prepared to pay for that?
Yeah.
Because it's in the end, as you said, it's like, we can get it within seconds, within milliseconds, but it's going to be a cost on that.
Right.
And it's just, if it doesn't bring a value that is valid or accordingly to the cost, why the need for it? So I do agree. There's some type of data, as you can, if you need to take action quickly and you can act on it, well, of course, then it might be worth it. But if you say, even if we know that we can change the route of the delivery, but if we don't have anyone to do that, well, it's just a waste of time and money.
Yeah.
So I think, we talk in just in time. That is a concept that has been maybe not that modern anymore, but still with data, I think it's about that. Because you have different levels of importance, but it's always a price. And I think it's very important as a customer when you're implementing to see, what are we prepared to pay for this? And not be afraid to go to the business to say, you know what, if you get the data within 3 minutes, it's going to cost you $20,000 a month. If you wait to 15 minutes, you're going to pay $1,000. What is it worth for you?
Yeah.
And often I say, okay, 15 minutes is good enough for us.
Yeah.
Okay, let's start there. So I think it's a really valid thing, and you should always put a price on data.
Yeah.
And it should be compared to the business value it gives. Otherwise, it's not that useful.
You're not the first people to say that, and in fact, I think engineers tend to be quite good at quantifying and saying, this is going to take this long, cost this much. But business people aren't very good at saying what the value of the thing they're asking you to do is.
Yeah, yeah.
Like, you say, I can do it for $20,000 in less than a second. What is the value of the thing you're asking me to do? And they're,
Well, it comes down to some plats where it's can you monetize that performance? And we've had cases, and I'm sure Max has as well, we don't need the performance. An overnight report that takes 13 hours is fine because we run it on Friday and we want the answer on Monday. But it's a paradigm shift that you can actually deliver to that customer if you actually find a way that they can monetize that information by getting the report and actually not running it on the Friday. What happens if you can actually run it on Monday? And so instead of closing your business on Friday, you're now closing your business at 8 o'clock Monday morning, and the end user is actually now running the report. And actually, they're not running a 13-hour report, they're running a 40-second report. They're all running 40 seconds report. All 40 of your delivery people, they run the report there and then. We had a prime example of that the other day, where you place an order with Amazon, which says if you order within the next 2.5 hours, you can have it delivered tomorrow. The interesting part there is if you cancel within an hour, you don't have to have it delivered at all. You can cancel the order. Now, you can't do that if you close your business on Friday, because this is Sunday and you're having it delivered on a Monday. And that's the exciting thing about data in motion and the other topic, was it event-driven data? It's like getting those events and being able to handle them. To make or break. And if you'd had that delivered, what's the cost of not actually actioning the don't deliver message? Well, that's actually the end user's got to go and take the product, go back to the shipping company and send it back to you. And if you're doing no cost returns, that means that you're shipping it out at cost and you're shipping it back at cost. Somebody has to pay. So my take on this is, what's the cost of not doing it quicker?
There certainly is an opportunity cost, and the question is if there's a smooth transition from the existing product into a product that's an entirely new product. So for example, same-day delivery is presumably a service that a customer would be willing to pay more for than one that goes over 3 days, but requires you to change your organization and maybe have data in motion and being able to accept that order, before 12 o'clock in order to deliver it the same day at the time. Is there a smooth transition to the way of doing business now, or do we need to have product owners for these capabilities that sort of see the end-to-end picture like you were just describing? Because it's not just some IT person that is responsible for an SLA of some arbitrary IT system. It's actually a business manager that owns a product or a service which is dependent on the SLA of an IT system, and there's this long chain of dependencies. Yeah. Can you transition from one product to another like that, or do we need to have a company see itself as data-driven and then assign product managers and then develop these capabilities depending on the product vision and that kind of stuff? I mean, how do you see these capabilities developing? So, for example, streaming capabilities and that kind of thing.
Yeah, I think it needs to be driven by actual product use cases and actual new maybe lines of business or even updates to the product. It needs to be driven by the product needs, because data engineering teams historically have been very technology driven, and so we get excited about new technologies and the new ways of doing things, but it's not necessarily something that's adapted to what the business needs or something that has actual business value. So I think it needs to be something that's defined end-to-end with a clear product value, a clear addition to the business, and that then drives the whole initiatives and the whole update to the data architecture and the technical stack underneath. If you need to introduce new technologies, then it's fine as long as you can connect it to an actual product improvement or actual business value. So I think it's important to have that vision before you start. Otherwise, you'll basically just build exciting technological things without clear business value and clear product.
There's nothing wrong with that, but if I give you a more dream scenario, if we pretend that cost isn't an issue, is there any reason not to go as fast as possible?
Fast in the sense?
In the sense, what kind of problems crop up when you move from something which is more batch-oriented to something which is more real-time, in motion, and that kind of thing?
I think it's the complexity of a solution, because historically data engineering teams have been working on building tools and technologies for batch-oriented pipelines. Like if you look at how we do batch today with tools like dbt, with how we're implementing data quality with tools like Soda. So there has been a lot of emphasis on building robust batch pipelines on data platforms. With streaming, I think the fact that the technology comes with a lot of complexity, with a higher complexity bar, pushed many teams away from using streaming in use cases where theoretically it would have been the better option. So I think there's that technical bar, but it's still a bit high for data engineering teams, because if you focus on streaming, you can deliver maybe one initiative, whereas if you do it in batch, you can deliver more capabilities, you can build more data products, and eventually deliver more value to the business.
What would you say? I mean, are there any downsides to, is there a way to over-dimension the system to your disadvantage, aside from cost? Because we know Snowflake is so cheap that if you upscale the system, you get the, and who doesn't want to have answers instantly? That's what I feel with Julia. It just goes so fast, it's nice.
I think, yeah, absolutely. And I think, I mean, I think it's more, I mean, can you manage that? I mean, do you have the capacity to handle it? If you get all the answers directly, I mean, can you act on it? Does it give you anything, any benefits in that? I mean, it's more of an organizational thing in the sense of, sure, we can deliver things as fast as possible. We can just throw money on the problem, and I mean the beauty of the cloud, we have the scalability, so we can just make it fast. But if I cannot act on it, and I don't have the capacity to do it, it's kind of useless. I mean, because I do need to put some effort on it. I need to put in engineering. I need to build these complex pipelines and so on and so forth. So I think in the end, of course it's nice. But is it useful? Does it bring me any value? Can I do anything with it? I mean, of course, you can. I mean, if you get your models trained as fast as possible, you can recalibrate and retrain and hold that process. But I mean, as you said, if you write music, I mean, will you do multiple songs, or will it just the quality be effective after a while when you can deliver it too fast in that sense? So
I'm somebody that believes that music analogies are perfect in every scenario. So let's run with this music analogy. There is something to be said for doing unnecessary work, which is that you learn a lot in the process.
yeah.
Is there something like that when it comes to setting up these systems, that there's something worthwhile in doing it the hard way?
I mean, I'm a true believer in keeping things simple.
Yeah.
And I mean, good enough is often good enough. I mean, the last 20% might not be worth it.
I'll quote you on that one.
Yeah. I mean, I think it's more of an experience thing for me, at least. It's a long learning curve.
Yeah.
I have been in this business for 30 years. I have done it the hard way.
Yeah.
And I can see it like, is it worth to do it, the extra effort?
Yeah.
If it's good enough. I mean, it's like many things. And I mean, if we go back to machine learning, it's the difference between, 85 and 87% accuracy. Is it worth it to go there? Well, it depends on how good it was before, I guess.
Yeah.
So I mean, everything is based on your baseline.
Yeah.
And you don't need to be perfect, because I think you're never going to be perfect.
Yeah.
And you quicker you can figure out what is the good level, then you can start iterating again. And I guess, as you said, I mean, doing music is, you get to a level and then you get stuck if you're trying to make it perfect.
Yeah.
Then you will, tune this forever.
Well, I mean, here's the thing. When you're writing music, the more songs you make, the better you get at making songs. Much better than if you'd spent all that time on a single song trying to make it perfect. If you make 7 songs, the 7th one will be much better. No, well, I'm saying you get good at making songs. So at the 7th song, if you're like, okay, I'm done. The 7th one is going to be so good compared to if you had just spent all that time on a single song trying to make that one song perfect.
Yeah.
Because the experience you build up from failing and doing again and again.
You raise a good point there. That it's learning by failure.
Yeah.
Quick, method of quickness to failure. Fail fast.
Yeah.
The old attitude. Sprinting, agile. Let's go back to some of the basics of DevOps and things like that, where you've got an old-fashioned, should we say old-fashioned, waterfall method, and we're going to document what we're going to do, and we document it for 4 months. And the reason that we're doing that is because it's going to take another 6 or 8 months to bring it into fruition before you can get the first user to use it. And during the time of development, you might change 3 or 4 people out of that development team or more. They might come and go, and they're still documenting it. Whereas in an agile environment where you maybe let's go to 2-week sprints or 1-month sprints, you get the team, you get the people, the chances of the people who are developing that part of it leaving in a month is quite short compared to the bigger systems. So the documentation that you need is not for an absolute beginner to come along, it's for a competent person to come along. So, let's get the pro code side of things here at the moment. So as long as you've got a capable person who knows the languages, he kind of knows the product, as long as they can pick up that documentation and work with it, then you can move forward. The same is there for DataOps. DataOps, DevOps, similar, but not the same. DevOps, you're looking at the code, the application is the goal, whereas in DataOps, it's the data that's the goal. And as long as the code that you're using to process it all works and does its job, it doesn't matter what the code actually is. Going in line with you're talking about multiple pieces of music being written, that's watch that stack, watch your management stack. Make sure that you've got enough monitoring in place, and then make sure you're auditing your monitoring. It's a multiple layers. And then if anything happens, you know where to go to find out what's wrong. And understanding the data which you've got, the endpoints, I think that's the critical part, which brings in again what we said at the very beginning, governance and privacy controls. And to what Max said earlier, collaboration. Make sure that the IT people are collaborating with the business unit owners. The business unit owners can know what the data's supposed to be. The people in the middle just know that they've got data going and there weren't any errors, but they don't know that what you're processing is actually doing the right thing. So,
I want to ask you about designing to destroy and redesign in the short term. But there's one thing I'd like to explain to the audience with regards to technical debt, is that when you calculate on the return on your investment, you have to calculate it like an integral. And so you have an opportunity cost when you have a project that's not in deployment because you haven't deployed it yet. So you could be making £1 million crowns a month, but it hasn't been deployed, and so you're not making that until it is deployed. And you've been pushing it forward because you're saying, if we do the documentation now, we'll save money. The documentation is only going to cost us 300,000 to make now, and if we do it later, it's going to cost us 700,000. But you have to calculate the integral, because if we deploy it now immediately, we're going to start making £1 million crowns a month. And so that cost is offset. So there's many engineers that I've been speaking with today and even outside that are like, tech debt is the end, the most evil thing that exists. But it's a question of margin with respect to the value of the thing that you're implementing. And if the integral is positive over time, tech debt is not a problem.
Yeah.
But, so we come back here again to, let's just assume we're going to pay for destroying and redesigning and that kind of stuff. But now it's really because of necessity, because things are changing so fast. Is that something that you see in projects, that are things being designed to be destroyed and rebuilt quickly, or are things being designed as if they were going to live for 6 years, making it so much more painful to destroy and redesign it when they actually have to do it? Like, people are surprised, oh no, we have to rework this now after 3 years.
I think in data engineering, there's an awareness that you need to have a solid foundation as your first supporting blocks that allows you to then design and build quickly and fail quickly. And if you need to rebuild something, you don't have to start from scratch. So again, if you look at something like the tools that we're currently adapting, it's similar to what has been happening in the software engineering world. And if you go back to things like DataOps, like trying to automate how you build, how you actually deploy something. So the cost of rebuilding something is much lower now than it was 5 years ago. And that allows data engineering teams to actually go and build more stuff, deliver business value now, even if it's not something that you will maintain for 5 years or for 10 years, but you're delivering business value. And I think especially now in this climate, it's important to show the importance of the data team, the importance of delivering value via data. And then as long as you have a solid foundation that allows you to ensure that if I want to rebuild this, I can start from this foundation. I don't have to start from scratch. I have a platform that allows me to test what I'm deploying, to monitor it, to ensure that if something needs to be changed, I can change it quickly. With that in mind, I think data engineering teams now have the capacity to go and build stuff, deliver business value as soon as possible, and then eventually you'll be able to revisit that when it's the time to maybe rebuild or to redesign it.
Do you see people taking this approach of designing for destruction to begin with? In your case, I think specifically, I have had some friends that have been talking to me about how they design databases that are rebuilt every night.
I think it's easier now than ever, and I think it's also we have with the whole DataOps and everything, we have a better mindset around these things to keep things small, to separate things that they do that. I can see, successful customers is very successful. They see it like that they can anytime redesign something. They build smaller units that they put in production that they can change in any time. But as you said, like, make sure they have a kind of a foundation, doesn't throw away things so they can go and interact back. We also see a lot of, when we talk about legacy, so we spend a lot of time, a lot of our customer comes from a legacy data world, where maybe in the beginning the trend was we're going to redesign this and it takes forever. Where they now say, let's just move things to something new, and then we destruct it after we are there and we can start building new things. So I think it's a maturity thing, but I think it's starting to adapt more and more to see data as something that is living.
But is that a valid thing? Is it just that way because it is that way, or is it a valid approach to design for destruction?
I think it's like we said earlier. It's like failing fast, testing things. But I think it's a good thing to see data as something as a more of a product, as a system we build, and not seeing it as we might have seen it before. That is something that is, we build this data warehouse, it's going to live for 15 years, and we all know that after 6 months it's invalid because everything has changed.
Yeah.
And starting to think of it more like this doesn't need to be forever.
Right.
But the whole cloud and everything has enabled us to do that very easily. So I think it's a good thing.
That's a great segue to a question I have here, which says
Sorry for that.
on-premise versus cloud-based data lakes.
Oh, yes.
When to use which option? This is funny that they phrased it cloud-based data lakes versus on-premise-based data lakes. I have a couple of not customers, but potential customers that have said, we're having a hard time, can you come in and help us? I'm like, oh, what's the issue? We've built our own Spark data lake in-house, and I'm like, oh my God. My middle name is do things the hard way, but not that hard. Sometimes you're just giving yourself a hard time unnecessarily. But I would like to leave that question as is, on-premise versus cloud-based data lakes. Ask what you guys think of that, but also add some nuance, which is, I'm a big fan of personal workstations that are very powerful. So, I have an HP machine myself with many GPUs, and it's snappy, it's good. It has Opteron disks that is just blazing fast. It's a pleasure to work on. You can't get that from the cloud. I mean, it's hard to get something like that and cost justify it specifically. So I believe in a very hybrid setup, and I think there's a difference between development, deployment, and a number of other things.
Yep.
What are your takes on this?
Okay, from the outset, our product from Actian has been an on-premise stroke hybrid stroke cloud. So everything works the same depending on how you want to use it. It's your choice, which I guess is one of our USPs, and cloud native is another USP for Snowflake. It's just like everything works in the right way. From your perspective of having this really high, powerful workstation, I'll relate that to customers who have production lines running. Production lines, OLTP, transactions that go through the absolute latency, as you indicate, to a cloud. You can't run a production line that needs to respond within 3 seconds, guaranteed all the time, because otherwise your production line slows down, and that means you can't make money. It could even stop if the response doesn't come back in a timely fashion. When it comes down to the data lakes, I would say that an on-premise data lake is not the thing to deal with, and certainly a bespoke on-premise data lake, even a cloud-based data lake, which you don't have control over, is better under any circumstance. Because we dealt with one time a company where all 6 of their data engineers had actually left. It wasn't one of our customers. It wasn't one of your customers, but they all got pinched by another competitor. And so they ended up with this on-premise data lake, data warehouse, and they didn't know what was inside it, and they had nobody that they employed who could manage it. In the cloud, at least you've got a position where you may not know what's inside it, but you've got it under a fully managed service. And I think that data lake in the cloud is the only place for it to be today. But everything has to be looked at on a security basis as well. You've got greater control and greater of security and governance if it's on premise. You can air gap it so that nothing can get to it. So that's the secure environment, which could be government type stuff that has to be dealt with. Balance that against the cost of the cloud and the ease of scalability. Scaling an on-premise one, where you've got to go out and buy new hardware, that's a lot of capital expense. Whereas if you need to scale up a cloud lakehouse, big, then shrink it back again, then you can do. And it runs as an OpEx cost, which I think OpEx cost is just brilliant these days. It's sort of taken the heavy lifting out of building a data center, and it's on trend. Go cloud.
What do you say, on-prem, cloud?
Yeah, I have to agree. I think that for most scenarios, cloud would be the better option, especially if you're getting started. It gives you flexibility, and also it allows you to start faster, because with cloud, you have many managed services, and you don't have that additional step of maintaining the infrastructure and also dedicating engineering time to just building. Again, think of the Spark cluster. You have a lot of engineering time that goes into managing that, whereas on the cloud, the engineering time goes into building your actual product, delivering value from the data that you have. So I think in most scenarios, cloud makes the most sense. But then, as you said, there are scenarios like if I'm developing, And if I want to test things, I should be able to test them in a smaller environment, or an environment in which I can run experiments without incurring the costs that come with cloud. There are also scenarios where you reach a certain scale. There are a few companies, for example, if you mention Uber, the scale at which they're operating, it doesn't make any sense anymore to be working on cloud. So you need to make that investment and have your own data centers and maintain your own data infrastructure. But I think it's very specific use cases where you need that. In most scenarios, cloud will get you where you want to be and allow you to dedicate your engineering resources, which are something that's very difficult. It's difficult to hire 20 data engineers to maintain your data warehouse or your data lake. So I think it allows you to get your data engineering time and your engineering time as a whole, working on the product, working on delivering value, and the cloud platform manages everything else for you. And it's like, even if you look at Snowflake, it's one of the selling points is that it makes it easier for you to get directly to just building data assets and delivering value.
Yeah. I mean, doing things the hard way has value when the thing that you're doing the hard way gives you a competitive advantage relative to your competition, making it worthwhile. But if the thing you're doing the hard way is something that can be bought on tap easily in the cloud, why are you making things hard on yourself? So presumably Uber or whoever that's doing things in their own data center with like doing things the hard way are doing something so unique that they get an advantage by doing it cheaper, more compactly, faster, and whatever it is. Netflix, where streaming large amounts of video is something that they can uniquely do in the way they do, it does pay off for them to have their own infrastructure for that kind of stuff. I just don't see that data lakes is one of those things anymore. It's so accessible. You have to grant it to Snowflake. It's easy to get going.
Yeah.
And so why would you make that part the thing you spend giving yourself a hard time about, when there's lots of other things you can give yourself a hard time about?
Yeah, true.
Like making your specific algorithm much faster within Snowflake. Now that you can run, what do you call them, UDTFs in Snowflake?
Yeah.
Why don't you make that code faster instead of spending time making Snowflake faster or something like that?
Yeah, that makes sense. I mean, of course.
But then here's the question. So so what's your view on like the cloud versus on-prem? When is it right to do which?
Well,
Aside from the data lake part, because I assume then you would say that on the cloud data lake makes most sense.
I mean, yeah, I should say that, right? I think the whole question is about on-prem versus cloud. I think it goes down to, regulations and security. Indeed, as mentioned before, I mean, we have certain companies, I mean, they cannot move things to the cloud. We have Intelco, for example, in Sweden, 5G data is not allowed to be anywhere. So you need to be very restrictive with that. So you always need to have, I mean, most companies doesn't have this issue, but some companies have. So you do need to have a hybrid strategy in certain cases. And I mean, as you said, when we have in manufacturing, where you do need to have the data, where you have your machineries,
right,
it's not the right thing. I do have run into one customer that actually kind of runs a data lake on premise, but they are handling videos. It's petabytes of data every day. And the reason why they don't do cloud, they cannot get it up to the cloud.
Well, that's a great point.
It's impossible for them.
I was thinking about that before, about this rip and replace stuff. It's getting really hard to move data around.
Yeah.
I mean, before it used to be that it was hard to get stuff out of Google because they would change it just the right amount that would make it basically impossible to extract data out of Google tables and stuff right now. But even if you can get it out nowadays, there's so much data that it would take you years to send it from one platform to another. Are we causing problems for ourselves with that?
I think to an extent, yeah, but also at the same time, I think because the volume of data is going to continue to grow. Like the data we're processing right now is much bigger than the data we're processing 5 years ago. So I do understand that if you bet on a platform and if you bet, for example, on data warehouse, eventually you'll get so much data into it that becomes a nightmare, as you said, to migrate something else. But at the same time, you need to also extract value from that data as long as you need to. And let's say I'm generating a data point today. In 5 years, it's not going to have as much value as it has today. Like if a customer clicks on a button today, in 5 years, that data point doesn't have much value. It still can be useful, but doesn't have as much value as it does of a data point generated today.
Right.
So eventually, we also need to learn to let go of the data that we don't need and to focus on the data assets that you actually care about.
Right.
And then if you do that, it will be easier for you to migrate to something else, whether it's to go to on-premise or another cloud platform. But you need to do that for the data assets that you care about, not all of the data that you have generated in the past.
I don't know. It's getting the data and looking after as much data as you need, I think is going to be the sort of on-trend case here. So you've got all of this data. How much of that data do you actually need to push up? If you go down to those, let's say some OLTP type data which you have in a data on-premise data, and you want to push that up to the cloud. Let's stay with structured on that side. Why are you pushing all of those last updated by, the last updated fields? So those are like very OLTP things. So I think part of not saving, not transmitting data is where we need to go. And that's where I try to focus with customers.
Or at the very least, capturing data with intent.
That's a good way to put it, yeah. Only having what you need for as long as you need it as well. We're very reluctant.
Like a life cycle approach.
Yeah, the life cycle of data.
Connected to the value of the data that you've identified.
Yeah, exactly.
Yeah, customers who've got retail data, for instance, so long as you've got, say, a complete 2-year cycle plus 3 months, that's probably all you really need for the whole real raw data. Maybe you keep aggregates for the next 3 years beyond that. And so you can't get back to the raw data in your warehouse, be whichever cloud database you're using, cloud warehouse, but you've got that extra raw data archived out there in a slow fetch place. So I think Amazon and Azure and Google have all got slow data. Places where you can store it cheaply for large volumes. Throw it in there in a format that you can get it back when you need it, maybe once a year. Regulation, I think, is another interesting aspect. Financial information has to be kept for 7 years. So that's 7 years. 4 of those years you probably never need to go back to again. So that can be taken out of your current warehouse environment. And with the great capabilities of our technology these days, everybody's technology out there, make another warehouse. Don't try to put everything in one place, which is what the old EDWs used to be. Have another warehouse.
Yeah.
You've got 27 customers. One's a big customer, 23 are small ones, and there's a couple of mediums in there. That, in my book, is 3 separate warehouse environments.
Does that make sense? Do you think you should make another warehouse?
You might. Not. It depends. I mean, I think everything, in all the aspects, things make sense in different ways. But I mean, the whole moving around in cloud, I think, big part of our business is to make data available in multiple clouds. That is what we try to solve in that sense. So,
there we go.
But still, it's, I would like to see standardized between clouds vendors in the way how things works, because in the end, it's infrastructure and it should be pretty easily to move around, but that is another discussion maybe.
I have one last question that I really wanted to spend a bit of time on, but we've been having fun with other stuff. So this is going to have to be a short answer from all of you. I feel like there is a bit of a shift now so that people that are working with infrastructure and people that are working with data science, and I know everybody wants to distinguish the roles. You have a data engineer, a data scientist, a blah, blah, blah. And people are really particular about this person should only be doing mathematics, not even code, because code is not mathematics. Anyway, coding does play a role in data engineering. Is the future code or no code or low code? I can say for my own part, I enjoy coding. I code quite a lot. I think I'm a fairly good programmer. And man, Copilot and ChatGPT just make me so much better. They make me twice as fast. And I thought I was good to begin with, and they just make me even more efficient.
Well, I'd say there's definitely a role for code because the algorithms that we use today to analyze the data, they're very codey. But there's also the place for low code and no code environments to allow the non-technical people, the business unit owners, to actually take part and actually deliver what they want without having to go through the professional coder.
Yeah, let's grant that SQL is a type of code as well then, in that what do you say?
Yeah, I totally agree. I think code will always be present, but then it's the personas that will be different. I think we're trying to get as many people as possible in the company to interact with data assets, to build data assets, and if someone is not comfortable with a coding language, it shouldn't be a barrier to build stuff with data. So I think eventually we'll have a mix of people using data, building stuff with data via no-code tools or via using user interfaces, but you have scenarios in which you use code. If you look today, the biggest tool that's in the data engineering space, dbt, is the tool that uses SQL, whereas you have tools that do it on the user interface but are not as popular. So I think code is here to stay, but also other personas get to contribute to the data platform.
We still need all three. I think it's the same way that AutoML hasn't replaced your job.
Right,
We always need people that knows, even if ChatGPT and all the Copilot can produce code, someone needs to verify and make sure it's the correct code and it does the thing that we want it to do. I mean,
At least for the next year.
yeah, I think so. And for a while, I mean, yeah, who will see? But
We'll have to place bets tonight, I guess.
Yeah, maybe.
All right. Well, I think we're out of time, and this was a surprisingly pleasant chat. Thanks everybody for joining. We didn't end up in fisticuffs, and we seem to agree more than not.
Yeah.
So, thanks everybody for joining, and I'll be seeing you in the next event very shortly. Thanks everyone.
Thank you.
Thank you very much.